Hello. Today's video is part one of exponential growth and decay. So we talked a little in the last video that when we were graphing a function, we looked at the graph to see whether it grew or decreased, I guess. So actually, let me back up here. So these two graphs, we had a growth where it started pretty flat and then jumped up. It grew really fast. The decay was when it started pretty high and then it dropped. So let's analyze the function a little bit more to see when is it going to be a growth or decay without graphing it. So number one here, or the beginning, we've got the starting value right here. So the A value is the starting value. So when we say starting value, it's really the y-intercept. It's really where it's crossing the y-axis. So let me add that, crossing y-axis. So it's not really the beginning of the function because it does continue over and hover along the x-axis. So let me reference back from the previous section. So right here is 3 on the y-axis. So that's considered the starting value. And so look at this equation right here. There's the A value is 3. That's where it's going to cross the y-axis. Okay. All right. The B value tells us whether it's growth or decay. So right here, if the B value is greater than 1, it's growing. If the B value is in between 0 and 1, so like a fraction, like a half or a third or like a decimal 0.5, 0.25, that type of thing, it's decreasing or decaying. And then of course here's your exponent. Okay, so that's going to tell you it's an exponential function. Now let's talk about that growth factor and decay factor a little bit more. So the factor itself right here, the B value is going to be 1 plus this rate. Okay, we'll get to rate here in a second. The decay factor is going to be 1 minus the rate. So what I want you to see is growth, there's a plus, decay, there's a minus. Okay, so think about increasing, decreasing, plus, minus, that type of thing. Now we're going to be given a rate because we're going to be analyzing some word problems. So our rate percentage, we are going to have to write it as a decimal in order to use it. So let's look at some examples to bring this together, and I will keep referencing back to the top so that it will start to make a little bit more sense. All right, number one, we are simply wanting to define, is it growth or decay? So let's come over here. The growth or decay value is based on the B. So the B is what's being raised to the power of x. All right, so I'm looking at 1.03. Okay, so I'm going to put here over to the side. So we're going to focus on the B value, which I see is the number 1.03. All right, if B is greater than 1, it's growth. If B is in between 0 and 1, it's decay. So 1.03, that's a little bit bigger than 1. So this is a growth function. Okay. Initial value. So initial value is our starting value. Okay, I'm looking for that A. So when I look here, so let me add in, I'm looking at the A value. So 600 here is the initial value. Now, if it helps, we could write above the function, I could write the general notation, y equals A times B to the x. And so then I can clearly align the A value and the B value. All right, let's find the value of y when x is equal to 7. So let's plug that in. So rewrite the function, but plug in 7 for x. So y equals 600 times 1.03 raised up to the 7th. And so we're going to need calculators here to do this. So we will probably get a decimal. So let's go ahead and just round it to 2 decimal spots. Okay, so go ahead and calculate it out as I do so we can see and make sure we match our answers. Now, if you're using a scientific calculator, I can just enter it the way it's written out. So I can do 600, and then I can use parentheses or the times button, 1.03, and then use your exponent key raised to the 7th. So I end up getting y is equal to 737.92. Now, if you don't have a scientific calculator, then what you need to do is you need to take 1.03 to the 7th, hit enter, then multiply by 600. You should get the same thing. Okay. All right, I want you to pause and do number 2. Different function, different equation, but same 3 questions here. Okay, so stop the video, work through all 3, and then come back and check. Okay, we have a decay function here. Okay, so I'm going to look at, since the b value is 1/2, that's in between 0 and 1. Initial value is the 5, that is the a value. And then let's figure out when we plug in 4 for x. Okay, so I've got 5 times 1/2 up to the 4th. Now, if you wrote it as a decimal, you might, now it does carry out and terminate at 4 digits. So if you wrote it as a decimal, this is what you had. Or if you have it as a fraction, that would also work, okay? Either one is fine. I'm just gonna kind of put a box around both. Since I don't really specify what to do. I went ahead and did not round the decimal because I could tell it terminated only at 4 spots. I didn't need to round, I could write all 4. Okay, all right, let's go on to the next 2 examples. Okay, so we have more of a word problem situation. So let's run through number 3 together. Suppose you purchase a car for $8,500. The car depreciates at an annual rate of 5.2%. Round your answer to the nearest cent when we get to working through things. Okay, letter A, write an equation that models the amount y that will be the value of your car after x years. Okay, so we are going to work with an exponential function. So y equals a times b to the x. So I need to figure out what I'm going to plug in for a and what I'm going to plug in for b. Okay, so going back. The a value is considered the starting value or the initial value. The b value will be our growth. And we're going to come over here. We have to figure out what b is equal to. So it's either 1 plus r or 1 minus r. Okay, so back over here. You purchase a car for $8,500. So that's going to be the start, or the initial. Okay, so we're going to plug in. I'm going to put an A by that. We're going to plug that in for A. Now, here is my rate. Now, I need to write that as a decimal. So when you convert a percentage to a decimal, you could say, well, if it's out of 100, you could do 5.2 divided by 100. Or the other way to do that is to shift your decimal to the right 2 spots because you're dividing by 100. So either way, the rate is 0.052. And so then I have to decide, is this growing or decaying? So I want to focus on the word depreciate. So that might be a word that you may or may not be familiar with. That means it's going down. So it's going down in value. So that is a decay. And so a decay is going to be 1 minus the r value, and we have the r value over there. Okay, so let's add a little to the equation. So y equals 8,500 is the a. And then I'm going to do parentheses because I need to do 1 minus the r, and the r is this decimal, 0.052. And then don't forget it's raised to the x. I'm going to have y and x as my 2 variables. So the only other thing I want to do here, let's go ahead and do the math here, and then we're going to finish our equation. So 1 minus 0.052 is 0.948. So our final equation will read y equals 8,500, and then do parentheses for times, 0.948 raised up to the x power. And go ahead and put a circle around that or a box. That is the equation. All right, so I can see that the 0.948 is in between 0 and 1. It's decaying, it's going down. And then I'm going to use this to model the future questions. So letter B, what is the initial amount? Well, we needed that to solve the problem. So the initial amount is $8,500. Oops. 8,500. Gosh, sorry, my handwriting is kind of messy. Okay. What is the decay factor? So that is going to be the amount after after the 1 minus r. So the decay factor is the b value. Okay, so I'm going to put here, initial value is A, decay factor is B. So that's our 0.948. What does the variable x represent in the equation? Let's come back up here. It says right there in letter A, after x years. So x is equal to the number of years. So I'm going to use the number sign. I can write the word number out if I want to, but number of years. Okay, how much would your car be worth after 4 years? So we're going to take the equation, and I now have 4 years. I now have an x value. So I'm going to take 4, and I'm going to plug it into the equation right here. So let's kind of rewrite. Y equals 8,500 times 0.948 raised up to the 4th. So we're just going to have to plug that into our calculator. Now we're dealing with money, so I need to round it to the nearest cent. So that'll take me 2 decimal spots. 8,500 times 0.948 raised to the 4th. Okay, so I have, this is dollars, $6,865, and that'll be 19 cents. So the car went from 8,500 down to about 6,800 in 4 years. And so that's unfortunately what cars do. They really drop in value. Okay, I want you to pause and try number 4. And either get through all of number 4 or come back to the video if you get stuck. Okay, let's see. I've got a couple things here. We're going to write our equation first of all. So here is where I'm going. Make sure, A times B to the x. All right, so I need an initial value, 150,000. The word appreciate means it's going up. So I'll be doing 1 plus the rate. And then the rate is 3%, but I need to convert that to a decimal. So that'll convert to 0.03. Okay, our equation, y equals 150,000, and then in parentheses, 1 plus 0.03 raised up to the x. Okay, and so then if I just simplify the parentheses, y equals 150,000 times 1.03 to the x. All right, so there's my equation. Estimate the value of the house in 2014. Okay, so this part right here, let me switch colors here. So the x is not just years, but it's the years after 2004. So I could kind of think of 2004 as like the starting point. So if I need to figure out all the way up to 2014, then I really want to take 2014 minus 2004 to see what my x value is. So that's going to give me 10. So that's going to be what I need to plug in for x to get my value. So I'm going to be plugging in the 10. So I'll be doing 150,000 times 1.03 raised up to the 10th. And I'm doing money again. 150 times 1.03 raised to the 10th. So I'm going to get a bigger number. So $201,587.46. Okay, so the price went up. Approximately how much was the house worth in 1994? Okay, so that's before 2004. So if I do, let me get rid of that underline. If I do 1994 minus 2004, I get negative 10. So now I want to plug negative 10 in for x. Okay, so plug in your negative 10, and I get the dollar amount of $111,614.09. So notice it's smaller than the 150. Okay, so we're going back in time. Okay, well that's part 1 here of exponential growth and decay. We'll look at a part 2 in the next video.